Chapter 22, Part 1. In this section, we will look at confidence intervals, but for two proportions. So comparisons between percentages are often more common than questions about just isolated percentages, just one proportion. We often want to know how two groups differ, for example, whether a treatment's better than the control, or whether this year's test results are better than last year's. It's very common to make these comparisons. So when we're making comparisons, what we're doing is looking at two proportion confidence intervals. Okay, I'm going to start with giving you the formula for confidence intervals. So typically with our one proportion confidence interval, we'd start with just a p-hat in the beginning. Now we're looking at two proportions. So what we're going to start with doing is finding the difference in these proportions. Now, if I were to leave it just like this, p-hat minus p-hat, it's kind of confusing. So to show that these are two different proportions, we're going to label one as p-hat 1 and p-hat 2. This first p-hat would come from our first sample. P-hat 2 would come from a second sample. We're still building an interval, so we'll have our plus and minus, our z-score, and then we're going to multiply by our standard deviation. Standard deviation is our big square root. We would start with finding the standard deviation for just the first proportion or the first sample. So I would take p-hat 1. I would multiply that by q-hat 1. And then I would divide by the first sample, so we're going to call that n1. Should look very similar to our one proportion confidence interval. Now that I have two proportions, I'm going to add on the second standard deviation. So I have p-hat 2 times q-hat 2 divided by n2. At first glance, if you look at it all together, it does look like kind of a crazy formula, but if you break it down, it does pretty much follow what our one proportion confidence interval looks like. It's just a little bit more complicated now that we have two. Just like we've seen with our previous confidence intervals, we do need to list our conditions before we start constructing and analyzing this interval. Since we're still working with proportions, many of the conditions that we'll check remain the same. So the first condition is still the same. I need to make sure that I have a random sample or that the sample represents the population. Oh, I'm sorry, I don't know why I wrote both. Sample represents population. Okay, the second condition is that 10% condition. We are going to have to check this for both of our samples, so I need to make sure that each sample is less than 10% of the population. My third condition stays the same. This is where I'm looking for at least 10 successes and failures. Because I have two samples now, I need to make sure this is true in both samples. There's one extra condition that we have here, and it's that the two samples are independent. So the first three conditions are the same as we've seen with all of our proportions, but we're now just adding on that fourth one, making sure that the two samples I'm looking at are independent of one another so that they're not impacting those p-hats or those percentages. All right, let's go ahead and look at our first example. Example 1 says, among randomly sampled teens aged 13 to 15, 57% of the 248 boys posted online profiles. That right there is our first proportion. They're looking at the percent of boys that posted online. That is compared to 70% of the 256 girls. So that's my second proportion. So big difference so far is that they're giving me two proportions. They're different. One's looking at boys, one's looking at girls. That should be kind of my cue that I am looking at a two proportion confidence interval. I need to calculate and interpret a 95% confidence interval for the difference between boys and girls' online behavior. So I'm going to start with listing out all of my variables. So I'm going to look at boys first. Okay, with those boys, the proportion that posted online was 57%, so I'm going to call that P hat 1. I can then find Q hat 1 by just subtracting. So that should give me 43%. I also like to write down that first sample size, so I'm going to call that N1. They surveyed 248 boys. Okay, my second sample was looking at girls, so I'm going to call this P hat 2. 70% of the girls posted online, so Q hat 2 would be the opposite of that, so 30%. And my second sample was 256 girls. I think it's nice and it's helpful to have those written out before we start actually working with the confidence interval. Next thing I'll do is check my conditions. I need to make sure my conditions are met. So the first one is that random. It says that these were randomly sampled teenagers. And that does apply to both groups, girls and boys, so we're good there. Next is my 10% condition. I need to make sure I'm checking both samples here. So I do believe that 248 boys, and I like to kind of group these together. So I'm going to say 248 boys and 256 girls is less than 10% of all boys and girls. You could write them as two separate bullet points if you wanted, as long as you're showing the grader or the reader that you looked at both of these sample sizes and you think that they're both less than 10% of the population. The next thing I'm looking for are my 10 successes and failures. So I'm going to start with boys. I'm going to take my 248, multiply by P hat 1, so that's the 0.57, and take 248 times the 43%. This will give me the expected number of boys that are posting online and are not posting online. Okay, so definitely greater than 10 for the boys. 2 samples, so I have to check the other sample as well. So I'm now taking my 256 girls, multiplying it by the 70% and the 30%. Definitely greater than 10 there. So both of those are good. The fourth condition is I have to make sure that these 2 samples are independent. I can't be in both of these categories. I can't be in the boys and the girls category. So I definitely think that my samples, you can say samples, or I sometimes just say groups, are independent. Cannot be in both groups. Okay, conditions are met, so we can move on to finding that confidence interval. So I'm going to start with just kind of following the formula we have above. So I'm going to take my p hat 1 and subtract my p hat 2. Now I know this is going to be negative because I decided to put the boys first before the girls. I will show you in a minute what happens if you were to reverse these. And then adding and subtracting. I need a z-score for 95% confidence. 95% confidence is my 1.96. And now I have my big old square root. I'm going to find the standard deviation for boys first. So 0.57 times 0.43 over that sample plus standard deviation for girls. Okay, I like to start with typing in just this difference here. And then we can type this whole thing in to find that margin of error. I'm typing it all in at once using that alpha y equals from my fraction template. If your calculator doesn't have the ability to do that fraction template, you might have to type things in individually, like type in this first one, add the second one, then square root it. Play around with it, make sure you get the same answer as me. You should get a margin of error of 0.0834. Right, just like we saw with confidence intervals, the first confidence intervals, I'm now going to add and subtract. Okay, now what does this mean? Okay, we have to interpret. So our interpretation should start off the same way as our one proportion confidence intervals did. So looking at my 95% confidence, I'm going to start with saying I'm 95% confident that, now we're still going to say the true proportion of, now here's the hard part, I have two proportions, right? I have boys and I have girls. Here's where it's important that you think about the order in which you wrote your confidence interval. We were looking at the boys first. So I'm going to start with talking about the true proportion of boys that are posting online. So I'm 95% confident that the true proportion of boys that post online is between, now I have two negatives here. Okay, what these negatives are, they're not really meaning a negative percent, but what those negatives are telling me is that the proportion of boys posting online is less than the proportion of girls posting online. So I'm going to say is between 21.34% and 4.66% lower. I'm using lower because they're both negative. What is it lower than? Well, it's lower than the true proportion of girls that are posting online. So our final interpretation says, I'm 95% confident that the true proportion of boys that post online is between 21.34 and 4.66% lower than my second group, the true proportion of girls that post online. Okay, one thing I do want to point out is that when we started making this confidence interval, we decided to put boys first and girls second. You very well may have flipped this. If you had them flipped, then this 0.7 would be before the 0.57, making this right here a positive 0.13. So when I take that positive 0.13 and I subtract my standard deviation, I now have the 0.0466 positive. And when I take it and add my standard deviation, I'm going to get the 2134 positive. So my interpretation would just be the opposite. It would say I'm 95% confident that the true proportion of girls who post online, because my girls would be first here, is between 4.66 and 21.34% higher because they would both be positive numbers than the true proportion of boys. Either way, you're saying the same thing on both of these. You're telling the grader that you know that more girls are posting online. In this first one that we did, you're just saying that boys are lower than girls. In this one, you are saying girls are higher than boys. Okay, if you're like me, I don't have much space here on the bottom, so I want you just to find like a blank spot somewhere on your packet. Could be somewhere that you've been taking like random notes. Find a blank page, and I want you guys to write down this general format for our two proportion confidence intervals. Okay, this is our template. I'm blank percent confident, so I'm 90% confident, I'm 100% confident, I'm 95% confident that the true proportion of our first group or your first sample is between blank percent and blank percent. So those are the percentages that you would get from that confidence interval. Higher or lower depends on, whether your percents are positive or negative. So if they're both positive, you'd say higher. They're both negative, you'd say lower. Maybe one's negative, so it's lower, and one's positive, so it's higher than the true proportion of the second group. Just like we saw with our one proportion confidence intervals, we can follow this template every single time. Okay, once you have that written down, go ahead and go to page 63 to look at a few more examples. All right, example 2 says the Centers for Disease Control and Prevention reported a survey of randomly selected Americans aged 65 and older. Found that 411 out of 1,012 men and 535 out of 1,062 women suffered from some sort of arthritis. First thing that we want to do is create a 95% confidence interval for the difference in the proportions. Okay, so a few things showing me that this is two proportions. They're giving me two groups. Men is one group, women is the other group. And they're asking me to make a confidence interval for the difference. If you see that word difference, it means we should be using two proportions. I'm going to start with writing out my variables again. So first group I'm going to look at are the men. So my p hat 1 would be this 411 out of 1012. Gives us 0.4061. Q hat 1, I'm just going to subtract that from 1, gives me 5939. Okay, your N1 would be the number of men surveyed, that is 1012. Okay, my second group is women. I kind of ran out of room, so I'm going to go up here. This is my P hat 2. So I'm looking at 535 out of 1062. So 0.5038. Q hat 1. Oh, nope. Q hat 2. 0.4962. My N2 would be the 1062 women. Okay, from here again, I need to check those conditions. Remember, every time you're making a confidence interval, you do have to check conditions. So first one is that it must be random. It does say that these are randomly selected Americans. And that works for both groups. Checking my 10% condition. I definitely think that the men and 1062 women is less than 10% of all men and women. Checking for my successes and failures. So I'm taking, well, for women, they kind of already gave it to us, right? So I'm going to have, well, I'll just write it out. I'm going to do 1012 times 0.4061. That should give me the 411. These are the men that had arthritis. If I subtract that from 1012, gives me 601 without it. Definitely greater than 10. Checking the women, so I have 1062 times my 5038 should give me the 535 that they told me had arthritis. Just going to subtract that again. 1062 minus 535 gives me 527 without, definitely greater than 10. Third condition, do we think these groups are independent? Definitely can't be a man and a woman, so I'm going to say samples are independent. Now, technically on the formula, what it wants us to do is start with our first p hat and subtract our second. But we kind of get to decide which one comes first. So I want us to put the larger proportion first this time. So I'm actually going to be working with women first. So I'm going to put that 5038 and subtract the proportion of men. If you have them flipped, you're totally fine. It isn't wrong. I just want us to do one where it's going to end up giving us a positive value out front here so we can practice writing that interpretation with positive numbers. Still working with 95% confidence, so a z-score of 1.96. Have my big old square root here. Finding my standard deviations. Order doesn't matter since we're adding, but I like to keep things consistent. So I'm going to start with women, multiplying P and Q, dividing by my sample size. Do the same thing for men. Gotta squeeze it in here. If you can't read that, that says 5939 divided by 1012. Okay, I'm going to start with finding this value here, just that difference. find my margin of error. Take your time when plugging it in. It can be very easy to mistype something. Should get 0.0427 after some rounding. We'll add and subtract. Okay, again, if you had these values flipped, so if it was reversed, you don't have to write this down, but I just want to show you in case you reversed it, your entire interval would be reversed, including the sign. So you would have negative 0.1404 and negative 0.055. Okay, I'm going to use this first interval that we have, not the one in purple, the one in black, to write our interpretation. So I'm starting with my confidence level. I'm 95% confident that the true proportion of the first group. So the first group I looked at was right here. That was the women who have arthritis. I'm going to say women with arthritis is between these 2%. So between 5.55% and 14.04%. Both of them are positive, so we're going to say higher than the true proportion of my second group, which was men. So then the true proportion of men with arthritis. Whew. So I'm 95% confident that the true proportion of women who have arthritis is somewhere between 5.5% and 14.4% higher than the true proportion of men with arthritis. So we're basically saying, I know for sure that the percentage of women with arthritis is going to be higher than men. It's got to be somewhere between 5% higher and 14% higher. Okay, does this confidence interval suggest that arthritis is more likely to afflict women than men? Yes, absolutely. We just said that we are 95% sure that the women are more likely to have arthritis than men. I know that it's somewhere between 5% and 14% higher, but I'm pretty confident that it is higher. If you had reversed these here, so you had your 0.4 first, you would be saying that the proportion of men with arthritis is lower than the proportion of women. So you're saying the same thing, you're just reversing the order. Okay, I want you guys to take a minute and try example 3. To save us a little bit of time here, I'm going to tell you that all of the conditions are met. So all of these conditions are met. You do not need to check them. What I do want you to practice doing is determining what that confidence interval is and then writing your conclusion, that interpretation there. All right, here is my answer for example 3. Hopefully you started out with writing your variables, P hat and Q hat 1. I was looking at males first and then females. I kept that order as I was doing my confidence interval. You might have this switched if you were looking at females first, and that's totally fine. Just keep in mind that your interpretation will be opposite. So if you did males minus females, you should get negative 0.0404 and negative 2.36. This means that I'm 95% confident that the true proportion of males who finished high school is between 4% and 2% lower than the true proportion of females. You may have it switched, in which case you would be saying that the true proportion of females who finished high school is between 2.36 and 4.04% higher than the proportion of males who finished high school. Part B said, does this provide strong evidence that girls are more likely than boys to complete high school? I said yes, but not by much, because it's only, 2%, between somewhere 2% and 4%. Okay, the last thing that I want to show you is how to check your answer using your calculator. Okay, in our calculator, we should be able to find a 2 proportion interval. So I'm going to go to Stat, Tests, and I'm looking for 2 proportion Z interval. Should be B, 2 proportion Z interval. Okay, it's going to ask us for a few things. X is the number of successes in your first sample. N is the size of your first sample. So if I do males first, I would do my 0.849 times my 12.460. Okay, keep in mind that this cannot be a decimal, so I'm going to round this to just 9. The sample size for that first group was our 12,460. I'm going to do the same thing for my second group. So I'm going to do my 0.881 times my second N value. Again, can't have that decimal, so because it's just 0.3, I'm just going to delete the decimal. And 2 was our 12,678. My confidence level is 95%. I'm calculating, and it matches mine almost perfectly there. Again, using that calculator is a great tool to check your answers if you're doing a free response question like we just did. It's also a great way to do multiple choice questions. Definitely on this one, it can take you a lot of time to plug that into your calculator, so I highly recommend using your calculator, that little shortcut, on multiple choice questions.